All right, let's talk multiplying rational expressions, multiplying and dividing. So let's just start with multiplying and see where we go. Now, the common rule for fractions is if I have a over b and I'm multiplying it by any fraction c over d, where these are terms, well, then I'll just get a times c over b times d, and I can just write that kind of cleanly as ac over bd. And that kind of rule is going to apply when I have polynomial expressions in my numerator and denominator. So let's take a look. So example 1 here, if I have 3 over 10, right, if I have 3 over 10, and I'm going to multiply by 5 over 9, well, then I'm going to say this is 3 times 5 over 10 times 9. And some of you are going to say, well, let's make this bigger before we make it smaller. No, always try and reduce where you can. So that's just going to be a 2. That's just going to be a 3. And what I'm going to get is 1 over 2 times 3. And that's going to be 1 over 6, right? So if we have a dot, that just means that it means multiplication. So what does that look like? So that was a nice grade 8 problem, grade 9 problem. Let's try this with some polynomials. Let's see what happens. So let's multiply x minus y over 2x, like that, and multiply this by x squared over x minus y all squared. And what happens is this is all going to become multiplication. That x minus y is actually one thing living on that bracket, and it multiplies the x squared on the other one. And let's bring everything in from the other bracket. That's 2x times x minus y squared. X minus y is going to be its own number, so that gets to cancel with that exponent, right? Everything is multiplication now. The 2 and the x, one of the x's cancel out from there, right? That's x squared over x, so that's 2 minus 1, that's 1, so a single x is left over. And what we end up getting now is x over 2 x minus y. Now, at this step here, we should take restrictions, and we know that x can't equal 0, and we know that x minus y can't equal 0, so x cannot equal y, right? Because at that point, I'm just going to add y to both sides, add y, and then I'll get x can't equal y. So those are my two restrictions, there and there, right? Those are values of x I cannot have. All right, let's try 3. Let's do another one. So we have x squared minus 25, and this is going to be over x squared minus 4. And we're going to see why this factoring is going to pay off so much. All this factoring we did before. This is 4x minus 8, and this is 3x minus 15. And what happens here, let's just factor and combine. So this is x minus 5, x plus 5, difference of squares. This is going to be GCF of 4, x minus 2 up there. That's my whole numerator. On the denominator, I'm going to get x minus 2, x plus 2, another difference of squares, GCF of 3, and this is going to be x minus 5. Everything is multiplication here, right? This is times, 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 times. Everything is multiplication. But since it's multiplication, I can cancel out like factors, right? I can simplify those like factors. X minus 2 and x minus 2 are alike. X minus 5 and x minus 5 are alike. And those are the only things that are alike. So then I get to go 4x plus 5 over 3x plus 2. And we're solid. We're golden. That's it. That's our answer. But at this point, I have to get my restrictions from this step here. And anything that's on the bottom, so x minus 2 cannot equal 0, x plus 2 cannot equal 0, and x minus 5 cannot equal 0. And what that means is that just means x cannot equal 2, x cannot equal negative 2, and x cannot equal 5. And our restrictions start from the before simplification, not after. Good, right? So we're looking for these binomial factors. Those are nice, easy cancellations. Now, for now, we're just doing binomials. Later on in mathematics, that's going to spread to even higher things, right? So right now, let's take a look. For number 4, we have x squared minus 3x all over x squared minus 3x minus 4. Okay, and this is all over the same fraction. and this is multiplying x squared minus 5x plus 4, and this is all over x squared minus 2x minus 3. Put it together, and we're just going to factor and put together what we can. So x and x minus 3. The next one, x minus 5x, x squared minus 5x plus 4. Well, two negatives, so it's going to be x minus 4, x minus 1. You can do the box method and check and see if that works for you. Okay. And now x squared minus 3x minus 4, so that's going to be negative 4, positive 1, so that's going to be x minus 4, x plus 1. Okay, and the other one here, that's going to be x minus 3, x plus 1, so this is going to be x minus 3, x plus 1. And notice how I get multiplication all the way across here, and now I'm just going to look for like and like. X minus 3 goes away, x minus 4 goes away. No x plus 1's at the top, so I can't do anything. No x is on the bottom. No x minus 1's on the bottom. So that's it. Let's take care of our non-permissible values. So it looks like I can't have negative 1, I can't have 3, and I can't have 4. Right? I have 3 non-permissible values there. Let's finish the simplification. I'm just going to get x times x minus 1 all over x plus 1 all squared, right? So that's it. So I have a repeat factor on the bottom. The repeat factor doesn't cancel out with itself on the bottom, right? It just stays a repeat factor there. That's it. And you can see, right, like I just am doing these restrictions by sight, right? I can see 4 minus 4 makes 0, negative 1 plus 1 makes 0, 3 minus 3 makes 0, negative 1 plus 1 makes 0. That one happens twice, but I only need to list it once because I don't need to say that it can't be negative 1 or negative 1. It just happening one time is enough for it to not be a non-permissible value. Okay, let's try a variation of this one. It's going to be kind of the same, kind of different. So we have x squared minus 3x again up here, but the rest is going to be different. X squared minus x minus 6, and then multiply it by x squared plus x minus 2. Put that together, and we'll get x minus x squared. And we're going to remember a very key feature here that we can use. So this is going to be x minus 3, multiply, this is going to be x plus 2, x minus 1 up top. So that is my complete fraction up here. On the bottom, this is going to be FOIL it, x minus 3, x plus 2. Right, so make sure that you check your foiling. Make sure that everything is what you think it is, x and 1 minus x. At this point, let's just get our restrictions. X cannot equal, well, it looks like 3, negative 2, 0, and 1. So negative 2, 0, 1, and 3. I just like to write it from smallest to largest, so most negative to most positive. So those are my restrictions. So I call them NPVs, right? Non-permissible values or restrictions. Let's take a look what we can simplify. This, x minus 3, x minus 3, x plus 2, x plus 2, x, and x. Okay. And some of you already know what you can do next, but let's just pretend we don't know. Well, x minus 1 and 1 minus x are not the same, right? If x was equal to 5, then I get 5 minus 1, which is 4, and 1 minus 5, which is negative 4, and then I'll get 4 over negative 4 is 1. But look at this pattern now again. If I take x equals 7, 7 minus 1 is 6, 1 minus 7 is negative 6, I'll get negative 1. And if I do it for 10, I'll get 9 over negative 9, which is negative 1. So something tells me that that this can still reduce to negative 1, because any value of x I choose, and you can try it out yourself, will get to negative 1. And the restriction is the same, right? I can't have 1 on either of these. 1 will create 0 for both of these. So something tells me that there's something I can do. And what I can do is take this bottom one and factor out a negative 1. And what factoring out a negative 1 does is that negative still exists, just that negative now lives on the outside, and I'll get negative 1 plus x because it changes the sign of each thing. But I can rewrite this as -1 just up front. And this is going to be x minus 1 over x minus 1. Now the factor is the same because 7 minus 1 is 6. 7 minus 1 is 6. 6 over 6 cancels out. But that negative is still there. So it's going to be just -1. Right? So this technique of factoring out a negative is going to come up over and over and over again. It's going to be very, very useful in order to get something in forms that we want. Let's do another one. A couple of these pretty straightforward, but it's worth taking a look at. X minus 7. Actually, I won't do that just yet. X minus 7 times x squared minus x all over x squared minus 8x plus 7. And this one is just like, if you don't have a fraction there, it just counts as over 1, right? So the new thing here is this is just over 1. Let's put all our factors together. So this is going to be x minus 7. This is going to be x minus 1. This will just be 1, but this is going to be minus 7, x minus 7, x minus 1, right? That's all. And it looks like our restrictions are going to be x cannot equal 1 and 7. So we're good there. Those are my NPVs. Awesome. Amazing. Gets to simplify, and I just get x left over. That's it. Just x. Perfect. Last example. Getting a little dicey, but we're going to make it work. 6x squared plus xy minus 2y squared all over 4x squared minus 8xy plus 3y squared times x minus y and 3x plus 2y. And anything that we multiply through, we're going to treat like extra factors, right? So 3x plus 2y. And here, 8x minus 12y over 2y minus 2x. We're going to use every tool in our toolbox for this. So let's factor the first one. First one should factor down into, oh, even I need to use box method for that first one. Let's see, 3x and 2x. And I have a positive middle. I end in 2. So that, let's see, what's that? 2 and 1. Let's see, that's going to be 6. That's 4. No, that doesn't work. Well, oh, let's try 2 and 1. And I can get 4 minus 3. So that's going to be minus 3 like that. And then I need y's on the end. Ah, yeah, there we go. So I'll get 3x plus 2y and 2x minus y. Right, and now I'll get times x minus y, and then take a GCF of this will be 4, and this will be 2x minus 3y. There's the GCF there. So I have all the factors for the numerator, right? Now all the factors for the denominator. For this one, let's see, going to be negative, negative, y, y. So negative 3, negative 1 for sure. Going to get to 8x, so this is going to be 2 and 2, 2x, 2x, because that gets to negative 6, negative 8, that's perfect, and then negative 3 times negative 1 is positive 3, perfect. So this is going to be 2x minus 3y, this will be 2x minus y, hey, we have some synergy here, 3x plus 2y, good, we're rocking in the free world. And this is 2y minus x. But I'm going to rearrange this y minus x. I'm going to make it nice and easy for us. I'm going to call this, that's just going to be a 2 in brackets here. I'm going to call this negative 1. And this is actually going to be x minus y. I'm going to factor a negative y out of that y minus x. And now I can do a whole bunch of stuff here. All right, 3x plus 2y. Yes, yes. 2x minus y. Yes, yes. X minus y. Yes, yes. 4 and 2 just becomes 2. 2x minus 3y. Yes, yes. So it looks like I have 2. Finally, I'm just going to have 2 over negative 1, which is just negative 2. Nice and to the point. right? So all it is we're using our factoring, finding like terms, like finding like factors, right? And remembering that everything results in multiplication, and we're good to go. Perfect. That's great. And stay tuned for part B.